Google DeepMind's co-founder just updated his timeline, declaring that human-level artificial general intelligence is plausible in the near future. To push past human constraints toward artificial superintelligence, they have mapped out specific technical milestones. They need autonomous research capabilities, self-directed goal formation, and cross-domain knowledge transfer. The tech industry is banking heavily on this exact trajectory. Right now, there is a $100 billion bet placed on building increasingly complex infrastructure to reach that superhuman ceiling. But scaling at this breakneck pace has created a blind spot. In the rush to build superintelligent systems, developers are ignoring deep structural flaws in how modern AI architectures actually operate. Take the multi-agent architecture. This is the industry's favored, highly funded method for tackling complex problems. The idea is simple. Take a massive task and split it across a team of specialized AI agents working together. A new paper proves multi-agent systems underperform single AI models. Adding agents shoots costs up linearly, while accuracy stays flat due to coordination overhead. Conversely, a single model using step-by-step chain-of-thought prompting beats elaborate multi-agent setups across all benchmarks. We are paying more for worse results. The current multi-agent trend is an expensive facade, proving tech companies prioritize convoluted scale over verifiable intelligence. We see a similar trend with the models themselves. Anthropic's new Claude Fable 5 recently launched to massive acclaim, hitting an incredible 92.7% on the SWE Bench software engineering test. Yet buried deep in the model's system card is a series of severe safety trade-offs. This system card shows the reality of the model's baseline reliability. The AI's hallucination rate on missing references has tripled, jumping from 6. A recent audit tested the major agent frameworks, the scaffolding developers use to turn AI into autonomous workers, against 6 basic safety requirements. 0 frameworks passed. These systems are structurally vulnerable. When the UK's AI Safety Institute was given access to test Fable 5, researchers managed to achieve full multi-turn jailbreaks in just 48 hours. This technical decay is spilling over into professional spaces. Translators, designers, and developers are actively pushing back against the flood of AI-generated output. A recent viral essay from a freelance translator highlighted exactly what the models get wrong, stripping away cultural nuance, flattening tone, and replacing professional judgment with automated mediocrity. This is the containment gap in action. The divergence between raw computational scale and our ability to control it is actively eroding the utility of the tools we rely on today. Instead of throwing a chaotic swarm of agents at a problem, developers are pivoting to a specific engineering discipline, Loopcraft. The idea is to design nested, self-correcting loops around a single AI agent. You must decide when to contract tightly for absolute reliability and when to expand outward to maximize leverage. This highly targeted approach is being supercharged by hardware advances. Developers are now running a 26 billion parameter coding agent natively on an Apple Silicon Mac, pushing out over 58 tokens per second. Because the model runs entirely on a laptop, it reclaims total data sovereignty. There are no API costs, no internet requirements, and 0 data leaving the machine. By moving away from massive cloud structures and bringing highly specialized models directly to local hardware, developers solve 2 problems at once. They close the containment gap, and they eliminate the privacy risks of shipping every keystroke to a centralized server. We are realizing that our current tools are vastly under-optimized. This visualization of a fine-tuning process shows why. Researchers discovered that a single parameter in LoRa optimization, the alpha scaling factor, is the dominant driver of performance. Getting this wrong nullifies the fine-tuning process, rendering compute investments useless. The data points to a clear reality check. Reaching human-level capability will not come from throwing billions of dollars at uncontrollable, bloated multi-agent swarms in the cloud. It will come from single-agent precision, optimized local hardware, and carefully constructed self-correcting loops that we can genuinely control.